In this lecture, we will study about plane electromagnetic wave and wave propagation. How wave propagate in different types of mediums. We have discussed formation of wave equation in the last lecture. We will begin from there and then we will try to give the idea of the waves propagation in dielectric medium. In this lecture, we will able to learn electromagnetic wave in vacuum and dielectric medium. I think all are aware of this dielectric medium. We have two types of medium, conducting medium or dielectric medium. In the case of conducting medium, we have some charges and the current may be there, but in dielectric medium there is no charge. But there is a difference between vacuum and dielectrics. Vacuum also have any charge and dielectric so, but there may exist the idea of displacement. So effect of charge on when we apply and there is no charge, then try to apply the field, they try to accommodate the field. So there is a difference here. Plain electromagnetic wave and wave propagation. How wave propagates? What happens when wave propagates from one medium to another medium? Of course, the detailed version of in conducting and other we will discuss in the higher classes or post-graduation classes. But here you will get the idea of propagation of waves, how wave propagates, and what changes maybe takes place when wave propagates in one medium to another medium. The study of these is very useful because as we know, in the last lecture we have discussed this, that light is considered as electromagnetic wave. So all the behavior of light can be explained using electromagnetic nature. If you want to explain interference, then you can explain using this nature. So that is interesting fact. The light studies, light can be not only given a special name like electromagnetic waves, but it also helps to understand more deeper knowledge about light. Plain electromagnetic waves, plain monocromatic waves in non-conducting medium. We have two types of medium, conducting medium and non-conducting medium. In conducting medium, we have charge to move, charge to propagate. But in non-conducting medium, nothing to move. We are not having any free charge. One of the most important consequences of Maxwell equation is the equation for electromagnetic wave in a linear medium. In the absence of free charge or current density, the Maxwell equation will be like this. Del dot D is equal to 0 and del dot B is equal to 0. Del cross H will give you del B over del T and del cross E is equal to del B over del T. You may have a question. We have discussed this in the last slides also, last lecture also. In that lecture, we use the thing with E and B. Here we are using the term D. D is the displacement current. We are adding this concept here because now we want to work with non-conducting medium, dielectric medium. So this will be represented by, in place of E, we are using D. We are also using here H, which is B is equal to mu 0 H. So now in place of E and B, we have added two more things, D and H. What is felt by the system? Electric field by the system is represented by D and magnetic field by H. Question from the right side, then you will get this. Everything is similar except we are using D and H here. The consequence of what we want to study here, vacuum and dielectrics. For uniform isotopic linear media, we have D is equal to epsilon E and B is equal to mu H. Here, use just concentrate on these two words, uniform isotopic. Uniform means the system is uniform everywhere, same everywhere. The values are everywhere in a moving, changing in a uniform way. And the isotopic gives us similar values. Isotopic quantities are the isotopic quantities are those quantities which are same in all the directions. No dependence. We have many types of system, isotopic and anisotropic. Soon this idea will be complex by these things. Anisotropy, non-uniform, but we will discuss these things in the higher classes. Here we are considering, for the sake of convenience, we are considering D is equal to epsilon E and B is equal to mu H. Why? Because the system is uniform isotopic. Epsilon and mu are the permittivity and permeability. In general, are complex function of omega. And here epsilon and mu are for medium. Initially for vacuum we have used mu 0 and epsilon 0. So we are changing the things, mu and epsilon, and we replace mu 0 and epsilon 0. But these mu and epsilon both are maybe complex functions. You can't say these are the similar real numbers. So complex is to use. And we will get del cross E. I am taking again, we have taken the curl from the both sides to del cross E is equal to something. And we modified it. So this will give you mu epsilon del 2E over del T2. Similarly, for magnetic field, we can write del cross E is equal to minus mu epsilon del 2B over del T2. Now these are the, you are getting again equations of wave equations you are getting. So it is shown that del cross E is equal to del of del dot E minus del to E, which is equal to minus del to E. Why we have done writing this? Because this term is 0. We have taken this del dot E by 0, and we have chosen this by taking non-conducting medium. If we have chosen, then we will get the answer. And similarly for del dot B. I think all of you might know this. Del Y del dot B is 0. Del dot B is 0 because there is no monopole exists. But electric monopoles exist. But by some constructions and assumptions, we are taking it as 0. So we will get two equations. And the interesting things are these equations are symmetric equations. Very similar equations we are obtained. Both are very symmetric equations. How can we say symmetric? Yes. One is del 2E. If you write del 2E, we are getting mu 0 mu epsilon del 2A over del 2. But if you are using del 2B, you will get the same equation. Mu and epsilon are for medium. This may be mu 0 or epsilon 0 if you are working with vacuum. This mu epsilon is giving you interesting thing, the velocity of light. If you write it in terms of velocity, 1 upon v square. You can replace this by 1 upon v square. Then you will see what happens. You will get the velocity of light. A coincidence that leads to lot of new achievements, new applications. We can deduce the equation for plane wave in vacuum. In vacuum, epsilon can be written as epsilon 0 and mu can be written as mu 0. If we take these two things and suppose we also assume that the electric field is varying only in one direction, that is, the electric field is varying in z direction, then it will be independent of x and y. So the equation can be written as d2Ez upon dz2 plus k square Ez is equal to 0. This is generally the equation of this wave. We have obtained the wave equation for vacuum. In this equation, k is called wave number, which is equal to omega by c. This equation is mathematically same as the harmonic equation, and Ez is equal to, the answer is epsilon e to power plus minus ikz. This is the solution. E is a constant vector. Therefore, the full equation can be written as ekzt is equal to epsilon e to the power minus plus minus ikz minus wt, or I omega t plus minus tau c. This represents a sinusoidal wave traveling to the left, right, or left. The another task is क्या क्या in a non-magnetic dielectric we have mu is equal to mu 0, so we can calculate index of reflection. The index of reflection may be n omega is equal to epsilon omega upon epsilon naught. So in non-magnetic dielectrics, this is your index of reflection. We see that the results here are same as in vacuum, except the velocity of wave. Propagation of, or the phase velocity is now c by n instead of c, and the wave number is k nw omega by c. So the behavior wise, if you are talking about vacuum or dielectric material, is same, but velocity will change, and velocity depends on refractive index, so it will change the direction also. This is a catching point, the difference between these two. Now, interestingly, if you know the refractive index, if you know the velocity, then you can find out many informations of light. We will discuss in other lectures. Thank you. I expect try to do these derivations several times, so you will learn the things. Exam point of view, it's a, it's a very important topic, and not only this, even in physics, it has a very important role. Thanks and take care.